All right, welcome to this next part. I believe it's part 4. We're going to be looking at some examples of using these special right triangle properties. These triangles, the process is all going to be about finding this constant that will unlock and allow us to solve the rest of the rest of the triangle sides. So in this case, we're only going to be missing one, though we could use this. If we just know one side, we can actually find out all the others. So anyway, without further ado, let's take a look at them. In this problem here, we have a 45, 45, 90 triangle. So even though this angle here is not marked, we do know we could use the triangle sum to figure out that it is a 45-degree angle. All of these triangles are isosceles as well. So you know these legs are actually congruent to one another. It's given that way, but even if it wasn't, we would know that to be the case. So now here, this is something that I like to do every time I'm looking at these special right triangle problems, is sort of figure out what side is what. So here, these legs are always referred to as my A, and the hypotenuse is the A times the square root 2. We're missing the A times square root 2 side, and we know the A sides. So in this problem, this triangle, we know that our constant, our A value, is 11 times the square root of 2. And we can easily solve for this missing side right here, this hypotenuse, by taking our A value and multiplying it by the square root of 2. Sounds sort of complicated, but it's not too bad. We're doing 11 square root 2 times square root 2. If you're not familiar with how to multiply radicals like this, you can just multiply those two numbers together. So we can do 2 times 2. That becomes the square root of 4, which is 2. So really this ends up becoming 11 times 2, or 22. So we know that the value of x, this missing side here, is actually 22. Another way of thinking about this is, since you're multiplying the square root of 2 times itself, what you're really doing is you're squaring it. You're squaring the square root of 2. Those operations cancel out, leaving us with just 2. Anyway, we found that missing side there of 22. And we'll keep moving forward. Hopefully we can kind of pick up some more pieces of this as we go on. All right. Here, this next one, this is a slightly different triangle. This is an example of our 30, 60, 90. We have the 60, we have the 90. The last angle here has to be the 30. Again, I like labeling my sides, the A, the 2A, the root 3A, those different things. So the shortest leg is always your A. That's the one that's the constant for our triangle. The hypotenuse is always the 2A. And the longer leg is the A times square root 3 side. So generally, when you do these problems, you may only be given one side. So you have to use that side to help figure out and solve for the value of A. But in this case, we actually have a choice. We're given 2 side lengths. Both of these could help us figure out the value of A. They're kind of equally easy in this case. They're not too complicated. This could be somewhat more complicated. So I'm going to go ahead and walk through what I would do to do this. So since I know that this is my 2A side and it is equal to 14, I can use that to set up a little equation. Solve for the value of A, right? Divide by 2. I figure out that A for this triangle is 7. Easy enough, right? I could similarly do the same thing with this side. Since I was given it, I might as well know that my A square root 3 side equals 7 square root 3. Kind of suspicious here. It looks like A is going to be 7 again, but let's go ahead and show that. If we divide both sides by the square root of 3, right? Divide by the square root of 3, those can just sort of cancel out. We find that A is 7. So A for this triangle, the constant for this triangle is 7. But generally, with these types of problems, we probably won't know 2 sides. We may only know 1. So we'll have to kind of, use only one of these things. Either way, that's what we were looking for. We were looking for the A side. So this side is actually just 7. That's it. That's all we were doing. All right, we'll keep moving forward here. You could feel free to pause it at this point and probably try these next two on your own. I am just going to kind of go through it. So here we have our 45, 45, 90. Easy enough. This one's 45 degrees as well, right? Anytime you know 2 of the angles, you know the third one as well. This side over here is our A side. This is our A side. Those are the legs. and this side is our a times the square root of 2. Well, this one's pretty easy. Since we know one of the legs, and we know that these legs will always be congruent to each other, we don't even really have to do much. This side is 3 square root 2, right? It's going to be congruent. It's going to be the same as the other one. And that's it. Yeah. All right. And then the last one here, again, I'll go ahead and label it. This one's a 30, 60, 90. So the short leg is the A leg, so to speak. The hypotenuse is 2A. And the longer leg is the A root 3. It might jump out to you already. We already know the value of A, right? This triangle, A equals 8. Pretty easy. So in this case, the side we're missing is the hypotenuse, the 2A side. 2 times 8 is 16. So this side, the one we're missing, is 16. And there you go.